Quantization? Wait, what was that again? Wasn't that like some kind of cooking technique? Or maybe it was something else? Well, whatever it is, that's what today's video is gonna be about. Okay, so we're still on the subject of image compression. And one of the steps we've mentioned is quantization. It's the one that comes after DCT or discrete cosine transform. This is an extremely important step in the lossy compression of images. What it does is drastically reduce the amount of storage space that the file takes up. And as always, it's important to remember here that the more you compress the file, the worse the quality is gonna be. Okay, now let's see how this whole thing works. So after DCT, the image is divided into a bunch of 8x8 blocks, right? And by the way, if you don't remember how DCT works, go ahead and check out our video on it. Now let's have a look at one of these blocks, which might look something like this. In quantization, what we're gonna do is overlay this table with another 8x8 table, called a quantization matrix. This matrix or table is also filled with a set of values and gets placed over the DCT matrix. Then what we do is take each value in the DCT matrix and divide it by the corresponding value in the quantization matrix. Oh yeah, and then the values are rounded to the nearest integer. The result is a new matrix like the one here. The point of all this is that, as you can see, the values in the matrix are significantly smaller, which means we can use a shorter code to encode them. So what that means is that the bigger the number you have in the quantization matrix, the smaller the resulting numbers are going to be. I mean, obviously, right? If you divide 80 by 40, the result's going to be a lot smaller than if you divide 80 by 10. And now you should be able to see why the numbers in the top left of the quantization table are smaller than the ones in the lower right. It means that the numbers in the upper left of the resulting matrix are bigger than the ones in the lower left. In our video on DCT, we saw that humans are better at recognizing edges than fine details, which means we can compress the values at the lower right more heavily than the ones at the top left. Remember, in DCT, the lower right is where the really high spatial frequencies are. You know, the ones responsible for those really crisp detail lines? Now, since the human eye isn't the greatest at picking up on these, we can compress them more. But we don't have to worry about it being too obvious. With quantization, on the other hand, there's gonna be a question of just how much compression we actually want. And it's always a balance. Remember, the higher the compression rate, the worse the quality. What that means here is weighing whether we want higher or lower quantization values. So like, when you make a JPEG, you can decide how heavily you want to compress the image. Which means that theoretically at least, you can use any quantization matrix you want. But the one we showed you earlier is actually a pretty standard one that's used a lot. So quantization makes it possible to compress an image in a way that strikes a really good balance between quality and compression rate. And then the next step is the one where we can take the values and encode them. Okay, so what do we need to remember today? Quantization is an important step in lossy image compression, where the components in the DCT matrix get divided by the ones in the quantization matrix. The result is a new matrix where high spatial frequencies are compressed at a higher rate than lower ones. This means the crisp detail lines get more heavily compressed than clear edges or broad areas. Still haven't had enough? Then go ahead and click on the next video!